So welcome to Chapter 2, Part 2. So now we're going to get into something called the types of measurement scales. Now remember when we said the measurement is just putting a number to something? All we're talking about is how you put the number to it and what that number means. So measurement scales, what you see right here, nominal, ordinal, interval, and ratio, are what are called measurement scales. What these mean is that different numbers in each one of these scales mean different things. So a number that is nominal would be different than a number that is ordinal in what it means. So when we put a number to something, it really it might mean different things depending on how much information is conveyed by that number. So for example, if something is nominal, the number just is a name to distinguish it from something else. So the most common thing that we think about here is on a sports team, let's say I've got a field hockey team, and they each have a number. So person number 10, right? If they got a 10 on, if she's got a 10 on her back, it doesn't mean that she's 10 times better at anything than the person who's wearing number 1. It just means that person number 1 is different than person number 10. They're different. That's it. Nominal comes from the Latin for name, right? So it just means a name. It doesn't mean a magnitude. It doesn't mean more or less of anything. When a number is ordinal, then it means that the number means more of something. So if let's say that we're doing stupid tricks. I'm making something up off the top of my head right now. Let's say that we are rating our impressions of Donald Trump, and you say that Jane gets a 3 for her interpretation of her imitation of Donald Trump, but Bill gets a 9 for his impersonation of Donald Trump. You're saying that Bill's is better, right? Because 9 is greater than 3. Okay? So if I get an 8 and Bill gets a 9, then Bill is better because 9 is better than 8, but I'm better than Jane because 8 is more than 3. So the order, the amount of magnitude of something means something in ordinal measurements. The order of it matters. Now we're not sure though that I'm exactly, or that Bill is exactly, 3 times better than Jane because he got a 9 and she got a 3. We just know that's the rating we got and that the number means more of something. When you have interval data, that means that the intervals between each number are equal. So the interval between a 9 and an 8 is the same as the interval between a 3 and a 4. Okay, all the intervals are the same. Now, what we don't have in interval data is a 0. So ratio means that not only are the intervals the same and that the higher numbers mean more, but 0 means 0 of the amount. Let's go through some examples of this and I'll show you what I mean. So starting with this, you tell me, what is your favorite color? Now you'll notice that on this list that I gave you, 1 is blue, 2 is red, 3 is green, 4 is brown, 5 is yellow. I'm not saying that 5 is better or more favorite than brown, right? I'm not saying that. I'm just giving a number to represent the difference. Sometimes we think of these as categories, right? So each category gets a different number. That's it. Just like each person on the hockey team gets a different number. That's all it's doing, is it's naming them a number. Blue is 1, 2 is red. It could just as easily have been red is 1 and blue is 2. It doesn't matter. The actual number only matters in that it is different from the other numbers. That's nominal data. Go ahead and answer this question. Now, when you do an answer to I like Nutella, you are giving a certain amount of disagreement or agreement. So in this particular case, the higher number means a greater amount of disagreement with the statement I like Nutella. So if you said 4, that means that you don't like Nutella very much. You moderately disagree with the statement I like Nutella. So that doesn't mean, though, that your liking for Nutella is exactly twice as much if you have a moderately agreed to compared to a neutral. So if you said 2 compared to 3, do I know that you have exactly the same difference in liking from someone who gave a 2 compared to a 1. I just know that 1 is more liking and 3 is less liking and 5 is a whole lot of disagreement going on there. I just know that the number means more of something, in this case, more disagreement. But I don't know that the interval between a 5 and a 4 is exactly the same as a 4 and a 3. In psychology, most of our data are actually ordinal, especially if we're talking about ideas of agreement, right? Especially on like a self-report, often we are going to get ordinal data out of it because we cannot be sure that the difference between a 2 and a 3 is the same as the difference between a 3 and a 4. Go ahead and answer this question. What's your current body temperature? You can guess. Now, it's kind of important that I said in Fahrenheit because Fahrenheit is the measurement scale, right, that we're going on. And Fahrenheit is an interval measurement scale, right? It's going to give us interval data. What that means is that the amount of temperature between a 98 and a 97 is the same as the amount of temperature between a 23 and a 24, right? The actual intervals are the same. So not only do we have the magnitude, right? So interval is also ordinal. We know that a 98 is more than 97, 97 is more than 96. So we've got that ordinal part. But we can also be sure that the intervals between each number are equal. They're the same. The amount of agreement between a 4 and a 5 is the same as the amount of agreement between a 9 and a 10. The intervals are the same. However, what does 0 mean in Fahrenheit? Does it mean 0 heat or 0 temperature? No. No, it doesn't. That's not what it means. That's why this is purely interval. Interval, by the way, is probably the least likely of the ones that you're going to see in this class because of that reason. Ratio is the same as interval, except that 0 means 0. So, answer this. How many minutes have passed since you last ate? When we talk about minutes, minutes give us ratio data. That means that 0 means 0 minutes. However, each minute is exactly 60 seconds. So we know that the intervals are the same. Each interval is 60 seconds. We know that 0 means 0 time. And we know that the higher the number, the more of the variable that we're talking about in this particular case. So if it's been 60 minutes since I last ate, then I know that I have exactly 60 times as much than somebody who said 0, because 0 means 0. All right? Nominal, ordinal, interval, and ratio. It is crucial that you understand the difference between the kinds of data that we get. It is really important, really important. The reason why it's so important is specifically because of nominal data. Nominal data cannot be calculated the same way as other data. Let me say this again. Nominal data cannot be calculated the same way as other data. Think about it. If I gave number 1 to blue and 2 is red, etc., remember that? Remember the way we did that for your favorite colors, right? So I took a bunch of people and I said, give me your favorite color. 1 is blue, 2 is red, 3 is green, etc. And then I went out and said, oh, well, it looks like the average favorite color is a 2.7. That doesn't make any sense. It doesn't make any sense because nominal data is just to distinguish the categories. It is just to distinguish. It is not meant to actually give something like a mean. So when we run statistics, we have to know what kind of data we have. And specifically, we need to know whether or not it's nominal. Because if it's nominal, we're not going to mess with a mean. We're not going to mess with the standard deviation. We're not going to mess with that kind of stuff because it doesn't make sense. It doesn't make sense. For you, when we're looking at a hypothesis, you need to know whether your independent variable, that's the IV, or the dependent variable, that's the DV, is nominal or not. You need to know what each variable is, whether it's going to give you nominal, ordinal, interval, or ratio data. And specifically, you need to know whether or not it's nominal because you can't run the same statistics on nominal data. And if you try to, you will get garbage. This is really important. Know your kinds of data. All right. There's a couple of other distinctions between data that we need to understand. So in the book, it talks about the kinds of data variables give as either continuous or discrete. So don't worry about the nominal, ordinal, interval, and ratio for this distinction. Instead, think about the idea of whether or not a decimal makes sense. So for example, in continuous data, a decimal makes sense, all right? Whereas discrete data doesn't make any sense. So certainly nominal data are all discrete. That's true. We know that, right? So blue is 1 and red is 2. Then a 2.5 really doesn't make any sense. Now, believe me, don't think you're like, wait a minute, maybe it's purple because no, don't mess with that. It's different. They're just different. Another way that this can happen is if you've got something like the number of siblings that you have, it doesn't really make sense to try and say, oh, I have 2.7 siblings. That generally is not the case. We would consider that to be discrete, right? The number of siblings tends to be discrete, right? You don't have 8.6 siblings, you have 8 siblings or 9 siblings. If you have 0.6, we got a problem. So in the book, it makes that distinction. Now, in general, in psychology, however, we make this distinction, and this is the one that I think you should care more about. Instead of worrying about whether or not it's a decimal, we're going to chunk these together into 2 different groups. Continuous is going to include ratio, interval, and ordinal data. You will hear me refer to continuous data, and when I say that, I'm talking about ratio, interval, and ordinal data. Now, technically, you can have some of these that are discrete, but we're not going to mess with that. If you hear me say continuous data, I'm talking about all ratio, ordinal, and interval data. In real life, a lot of people argue as to whether or not ordinal data counts as continuous. You don't care, because in psychology we do this all the time. Now you can go take a grad school stats class and you can mess with that stuff. But for us, ordinal, interval, and ratio, that's all continuous. Nominal data we're going to call categorical data. So we're going to call it categorical. So ratio, interval, and ordinal is continuous. Categorical is nominal. And that's how we're going to distinguish between what kind of statistics you can run with your data, because you need to know whether or not things are categorical or continuous. If you don't know that, then you're going to get garbage out of your data. So make sure that you can distinguish between categorical and continuous data. Let's do some practice. Here's our practice. Remember, last time we talked about 4 participants, the number of cups of coffee they consumed, and now we also measured their area code, the hours of sleep, and liking for donuts. So, which one of these variables is nominal? Area code is nominal. And just so you know, the participant number technically is nominal as well. But normally we don't even worry about that. That's mainly meant to distinguish who is who. I'm not going to ever ask you, oh, on this, how many nominal variables are there? And I'm assuming that you're going to include the participant. I'm not assuming that. I would just be looking for the one, and that would be the area code. And why is area code nominal? Well, it's a number, but the 303 number isn't more or less of something than a 301. It's a number that represents a difference, a different category. That's it. It is just different. It is not ordinal. There's not more of anything just because you have a 303 area code compared to a 240 area code. They're just different, not more or less of anything. Okay. Which one of these is our ratio? The number of cups of coffee and the hours of sleep are both ratio. Now we're assuming in this case that the number of cups of coffee is equal. So let's say an 8-ounce cup of coffee would be equal, right? In which case 0 means 0 cups of coffee, just in the same way that 0 means 0 hours of sleep, right? And more means more, and the intervals are equal, right? So for the interval for cups of coffee, that's 8 ounces for each interval. And for hours of sleep, that's 60 minutes for each interval. Those are both ratio. Liking for donuts is what kind of data? Now we're assuming in this case that, assume that I say, all right, how much do you like donuts? Tell me on a scale from 0 to 10, with 10 equals the most liking. Liking for donuts is ordinal. Ordinal data. Liking for donuts is ordinal data. Ordinal data because a bigger number means more. So person 1 likes donuts at a 3. Person 3 likes donuts at a 2. Person 1 likes donuts more than person 3. But we don't know that person 1 likes donuts exactly the same interval, exactly more than person 3 in the same way that person 2 likes donuts more than person 1. We're not sure that the distance between their likings are exactly the same. We're not sure of those intervals. That is ordinal data. Which of these variables is categorical? Area code is categorical because categorical variables are nominal. Those are the same thing for us. They're the same thing. Nominal, categorical, for us, they're the same thing. Which of these is continuous? Cups of coffee, hours of sleep, and liking for donuts are all continuous variables. Anything that is anything that is ordinal, interval, or ratio, anything that's not nominal, is continuous. What we're caring about here is, does it make sense for you to get an average, right? If it makes sense for you to get an average, then you got continuous data. So ordinal, interval, and ratio data all give us continuous data. We're going to run different statistics on them than we would for the area codes. For example, because getting an average area code doesn't make any sense, we only care about distinguishing people in different area codes. All right. Last note. In this class, whenever I ask you for an answer, I want you to round to 2 decimal places unless I very specifically tell you otherwise. So, for example, if you get the answer and it's 3.44987, the correct answer that you should input is 3.45. You round to the nearest 100th place, okay? You go to 2 decimal places. Now, if you have a whole number, so for example, if the answer is just 3, then you can leave it at 3, and that's okay, right? You don't have to put 3.00. You won't be wrong putting in 3.00, but you don't have to do that. But if you've got more than 2 decimal places, then round it up to to 2 decimal places. Every answer should be rounded to 2 decimal places. If you give me more than that, then it will probably count you as wrong. So make sure that you're rounding to 2 decimal places when you are answering questions. That is actually an APA style thing. That's what we do in APA, but it'll make our lives a lot easier. 2 decimal places.